हेलो स्टूडेंट्स। आज के इस वीडियो में हम डिस्कस करेंगे सम न्यूमेरिकल्स ऑन गॉस लॉ। लास्ट वीडियो में हमने गॉस लॉ डिटेल से डिस्कस किया था। अब आज के इस वीडियो में हम कुछ न्यूमेरिकल डिस्कस करेंगे बेस्ड अपॉन गॉस लॉ। तो सबसे पहले स्टार्ट करते हैं क्वेश्चन नंबर 1। आई ड्रॉ द डायग्राम। Suppose a hemispherical surface is given and at the center a charge q is placed. Fine. And we have to find the flux of electric field through the electric field due to this charge. Like suppose this is emitting electric field lines. And we have to find the flux of this electric field through this hemispherical surface. So first we will do it by method 1. See, especially in this case we can do it without Gauss law also. See, since the surface is hemispherical and the charge is exactly at its center, so the field line must be radial to the spherical surface, that is perpendicular. So if I consider any small area, the electric field as well as the area vector also in the same direction. So always E and dA are at 0 degree. So the small flux d phi through this area can be given as E dot dA, that is E into dA cos 0 degree, that is simply E into d. Fine. So total flux can be given now. Phi is equals to integral of d phi, that is integral of E into dA. Now since the all the point on the surface is equidistance from this point charge q, which is equals to its radius, say it's r. So the electric field is constant everywhere on the surface of this hemisphere. So it can be taken as outside integral of dA, that is E into A, or E, and the E we know that the electric field intensity at a distance r from a point charge is given as q by 4 pi epsilon naught r square, and the surface area of the hemisphere is 2 pi r square. 2 pi r square. So this will cancel out 2 times, and it is finally pi is equals to q by 2 epsilon naught. So finally we got phi is equals to 2 epsilon naught. So this is the method 1. I'm sorry. So this is the method 1, and now we will do it by Gauss law. This was without applying Gauss law. Simply we used the relation, we used the speciality that E and dA is always at 0 degree. Now method 2 using Gauss law. That is very easy. first thing ki Gauss law is applicable for closed surface, and this is not the closed one. This is open one. This is open at the bottom. So do one thing ki make it close symmetrically. I will just do what? I will close it, uh, constructing the lower half also. So there is two half, upper and lower, and the charge is exactly at its center. So using the Gauss law and from the symmetry, we can say that the upper half and lower half both must be contributing same flux. Whatever be the flux associated with the upper half, the same flux must be associated with the lower half also. So let K a flux phi associated with this. So phi is also associated with this. And total flux from the Gauss law, total flux 2 phi must be equals to net charge inside it by epsilon 0. This implies that therefore phi is equals to q by 2 epsilon. So again it proved from the Gauss law also. You can see how easy we can do it with Gauss law. One more question we will do. Question number 2. Suppose a square is given of side length A, and it is lying horizontally, and above it, suppose at a distance a point charge q is placed. So definitely some electric field line emerges from this, which crosses this plane. Fine. So here also some flux will associated with through this surface, square surface, and we have to find the flux of this electric field E through this square surface of side length A. Then how we will solve it? See, the thing is that this time the charge has different distance from the different point on the plane. See here you can see the perpendicular distance list A, but here it is more than A, here also more than A. So at the different places of the surface, the field must be different. So here is a case of non-uniform field through the surface area. So if we will try to apply the definition E dot dA, its integral, it will be very difficult to find a function of electric field. But see, we can do it very easily with help of Gauss law. See, again, if I have to apply the Gauss law, what I have to do? I have to close the surface somehow. Surface is open, but Gauss law is not applicable for the open surface. So first I will try to make it closed. And equally it is also important that you should choose a closed surface such that the charge could be symmetric in all respect with the every surface. So the placement of charge must be symmetric. Then only this method can help. So I do one thing. Okay. sorry, do one thing, make it a by 2. Suppose this is a by 2. Make it a by 2. Then only it will be symmetric. Then I will do what? I will construct a cube of side length A. I will construct a cube of side length A. So this is a cube of side length A, and this is my bottom surface. This is given, and through this surface I have to find the flux of electric field, and my charge is at the center here. Here is the charge Q. So you can see that now it has been closed inside a cube. I constructed a closed cube, and this surface is at bottom. Now I can apply the Gauss law. So if phi is the total flux, if phi is the flux of electric field, now if phi is the flux of electric field through entire cube, then phi must be equals to Q by epsilon. From the Gauss law, we can say that the flux through entire cube surface is Q by epsilon naught, and since the cube has 6 faces and each faces is symmetric with respect to this charge because it is at a distance a by 2. So from each side it is at a distance a by 2. So due to the symmetricity, we can say that each face have the same flux. So 6 face have Q by epsilon naught. So flux through one face, flux, therefore flux through one face is phi dash is equals to Q by 6 epsilon. So in this way we can find the flux through a single face. Now a similar question, next question number 3. This time suppose a cube of side length A is given. Suppose this is a cube of side length A, and charge Q is given, is placed at one of its corner, and we have to find the flux of electric field through one face. Suppose I have to find the flux through this face. Then what to do? Again I will apply Gauss law, because it is very difficult to find it conventionally, because everywhere the distance is different on this surface from this point charge. So again it is the case of variable electric field, and it will be very difficult to find it conventionally from E dot dA in its integral. So instead we will try to close it. See, the charge is not closed, it is at the corner, so exposed to the outer space. So I will try to close it, and to close it I will form a bigger cube of side 2A. So I will form a bigger cube of side length 2a. Sorry. This is a bigger cube of side length 2a. So this charge will come at its center. Now this charge Q will come at its center, and the surface, the face on this side will divide in 4 equal, A by A. So this is something like, so this is one face of A by A, and here is 4 face. So I have to find through one, say this. So this is my required surface through which I have to find the flux. So again, if the total bigger cube suppose this total bigger cube has a flux phi, through all its surface area, through all its faces, then from Gauss law phi is again q by epsilon naught. Therefore flux through one big surface is phi dash is equals to q by 6 epsilon naught. So q by 6 epsilon naught is the flux through this one surface. Further, I need the flux through this. So since these 4 small spaces A by A is also symmetric in all respect with respect to this charge, point charge, all are symmetric, 4. So further it will be divided by 4. Further, therefore flux through one small face is phi double dash equals to q by 24 epsilon. So this is the final. First it is q by epsilon naught through all the 6 faces, q by epsilon naught, and q by 6 epsilon naught I got the flux through one bigger face, and further this 4 small faces is symmetric with respect to this charge q. So through one we can do it, divide by 4 further, and it is q by 24 epsilon. So for today's up to this. In next video we will discuss about dipoles.